Today we are going to look at the measures of central tendency. This is just a fancy term for averages. You've most likely heard of an average. The ones we are going to cover are the mean, median, and the mode. When you think or hear of the word average, most of us typically assume this to be the mean, but there are other types I will explore, as we'll see later in this video. Let's start with the mean. For both AQA and Edexcel, it should be assumed that in an exam scenario, if you are asked to calculate and work with the mean, we assume this to be the arithmetic mean, which is different to other types of means that we have. In GCSE Maths, probably even earlier, you would have learnt and used the mean with no official equation, at most a worded one, the sum of all values divided by the number of values. When I say the word values, for now, just assume that they are numbers of a list or dataset. The following part is just a bit of an expansion on the scheme of learning. It isn't particularly beneficial right now, but it is if you go into a higher level of maths, even later on when we look at standard deviation, another equation covered in another video. So here are the four symbols displayed. The first of them is an X with a line above it. We call this X bar. This is literally the symbol for the mean. To avoid confusion for later topics, it is a symbol for the sample mean. Next we have this E-looking symbol. This is called sigma, the Greek translation for summation. Next up is just X. This doesn't need much explanation other than the values which we will use. And lastly N, the number of values in the dataset. Now, if you compare this to the worded and more familiar equation at the top right here, it starts to tie in together. So I can rewrite using the symbols the mean to be the sum of X over N. With the formula now at the top left, we can now look at an example. The following numbers are 2, 3, 3, 4, and 13. Find the mean of the dataset. I simply need to first find the sum of the values. 2 plus 3 plus 3 plus 4 plus 13, and then divide by the number of values, in this case 5. We can then simplify this to 25 over 5, which gives us a mean of 5. Now, this value 13 here is a special case, if we look at it in isolation. The cluster 2, 3, 3, and 4 is a very narrow range. However, 13 is more than 6 times the size of the smallest number, 2. We call this an outlier, which is an erroneous measurement which skews the data. To understand how this affects the value of the mean, let's remove it from the dataset. So now we have 2 plus 3 plus 3 plus 4 over 4, the new number of values. This equates to 12 over 4, which is 3. While it doesn't seem a huge difference here, it still makes sense how 5 looks a little unusual since 80% of the previous dataset was between 2 and 4. Also note, we'll cover outliers in more detail when we look at the range and the IQR. The next average we need to look at is the median. Quite simply, this is just the middle value of a dataset. There is one prerequisite that you must always remember though. The list or dataset must be ordered. Sometimes exam questions are sneaky and mess them up, trying to catch you out. There's a formula for finding the median of a dataset. Well, 2 actually, but we'll just look at the first one for now. This is for ungrouped data. The formula is half of n plus 1, where n is the number of values in the dataset. The median of group data could be found using just half of n. If we are going to find the median of this dataset, we need to first order it. Now, using our formula, we can find that half of 9 plus 1, there are 9 values, means that the median is the 5th value, which gives us a number of 4. Now, you could just cross each end of the list to find the median here if you would want to. This example had an odd number of values which made it easier to calculate. Let's do another one which is a little harder. Pause the video and have a try. This dataset here also needs to be reordered, so we end up with this list. The median is half of n plus 1, so we will do half of 8 plus 1, which means as half of 9 is 4.5, we need to find 4.5 value. Now, bear with me, you just have to have a good think once, and after that, questions like this become a lot easier. If we know that our 4th and 5th value are 3 and 4 respectively, we can show this visually. Now, 4.5 value is halfway between the 4th and the 5th value if we draw it out onto a number line. That means, if it is halfway between the 4th and the 5th value, it must be halfway between the numbers 3 and 4, which gives us a median of 3.5. You can also calculate this using the mean of the two numbers. So just do 3 plus 4 and divide it by 2. The mode is the value of the dataset that appears the most. Note you can have 0, 1, or even multiple modes. Take this list for example. The mode would be 2, as it appears 5 times. Now think about this list. If you think that there is no mode, you'd be correct. This video is quite simple, so there will only be one quick exam question to test your knowledge. A student records the number of goals a football team scores in their last 10 outings. The numbers are 0, 1, 1, 2, 2, 2, 4, 5, 8, and 10. We need to find each of the mean, median, and the mode. Well, have a go. Make sure you've mastered this topic, as almost all equations you work with fundamentally build on these. For the mean, we have the sum as 35. Remember, you're always allowed a calculator for statistics, so make sure you use it. We also have 10 games, so we divide this by 10. So 35 divided by 10 gives us a mean of 3.5. For the median, we can use the formula and plug the numbers in. So we get half of 10 plus 1, which gives us the 5.5 value. Now, we don't have to do much work here, as the 5th and 6th values are both 2. So naturally, the 5.5 value would also be 2. The mode, being the value that we see the most, is 2 goals. Not much more is needed to be said here. Thanks for watching this video. Give it a like if it was helpful, and why not subscribe while you're at it. If you want to be part of the growth of this channel, share this with your friends.